All right, geometry 10.6. We got two more sections in this book: 10.6, 10.7, and then we'll give a little practice to circles and get you some more worksheets out there with some more challenging problems that we have so far. All right, so we got using segments of chords. All right, so what are we going to do today? Use segments of chords, tangents, and secants. And rather than looking at the angles, whatnot, we're actually going to look at another theorem here. The segments of the chords are two segments in the interior of a circle, then the product of the lengths. So we're going to talk about the lengths here, not anymore about the arcs or the angles, right? The product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Alright, so we have a chord, AB, and we split this chord up, AB, into AE and EB, and it's saying, well, if you split this chord up, AE times EB, and you have an intersecting chord, then that's also going to equal EC over times ED. So the product of the two chords, right? The product of the chord being split up in whatever ratio it is, will equal the same product of the other chord being split up in whatever ratio that is. Okay, pretty cool theorem. Let's see, and there's a proof, of course, on example 19, page 74. Okay, you try that. All right, so we have this, using the segments, we have two chords. So we got K, J, which is made up of Kn, so X times X plus 4. So that is the product of the first chord. And this should equal the product of the second chord, which is X plus 1 times X plus 2. Alright, cool. So we got some quadratics here. So we got X squared plus 4X equals X squared plus 3X plus 2. So sad. The squares go away, and X is equal to 2 after you bring over to 3, and you're done. Okay? And then, of course, if it's asking for the ML and JK, we'll then go back and find ML and JK. So we got 2 plus 2 is 4, 2 plus 1 is 3, so ML is equal to 7, and JK, we have 2, and 2 plus 4 is 6, so 2 and 6 is 8, and those are the segments of the chords. Alright, first example down, let's take a look at the next. Monitoring progress, alright, cool, so find the value of X. Alright, so they gave you some much easier ones here. So we got this chord broken up into 3, so we've got 3 times X is equal to 6 times 4, so X is equal to 8. Okay, and then the other one is 2 times X plus 1. Right, so I got this chord and this chord, right, that's one chord, times or equals 4 times 3, which is 12. So X plus 1 is equal to 6, and X is equal to 5. Alright, not too bad. They have a tangent segment. Alright, cool. So the tangent segment and the secant segment. Okay, so remember the difference between tangent and secant. Tangent touches at one point. Secant goes through and touches the circle at 2 points on the chord. Alright, and it's saying, okay, so we have secant contains chord, blah, blah. The part of secant is the external segment. Okay, so we have the external segment. And then the other segment. Okay, so let's see what they're saying here. So, they're saying here now the segments of secants versus tangents and secants. So I think I'll take a look at both of them. So just to get that in there. So EA, take that out. So we got EA times EB. Alright, so now so let's look at the difference. All right, before we multiply this segment by this segment, now we're using this segment, right, the outside portion of the segment, times the entire segment, right? So EA times EB, and that's going to equal, again, the outer part of the segment times the entire segment, right? So the product of the portion of the segment times the entire segment will equal the same product, will equal the product of the outside part of the segment times the entire segment. Alright, so let's take a look at an example. And okay, that's for you guys for later. Alright, so 9 and 11, so this one's saying 9 times, right, 9 plus 11, so the entire segment is going to equal 10 times 10 plus x, which is the entire segment as well. Alright, so we have 9 and 11 is 20 most of the time, so we got 180 is equal to 10 times 10 plus x, so how about 18 is equal to 10 plus x, and x is equal to 8. Right, and that's all it's asking for. Alright, so this is the algebra piece is easy, just making sure you know what to set equal to each other. If you can't do this part, then the rest of the algebra is going to be incorrect no matter what. Alright, so please recognize the difference when the chords are inside, when you have the chord on the inside versus segments and tangent segments or secant segments. Alright, next one. Alright, so we got outside segments, so both my segments are on the outside here, so be careful. So I got 5 times x plus 5, right? So I'm using this portion times the entire portion is going to equal 6, the outside piece, right? Times the entire piece, times the entire piece, which is 15. All right, so this is x plus 5 is equal to, so cross that out, make that a 3, and that makes it 18. So x is equal to 13. All right, so here my algebra was, rather than distributing in, I just divided both sides by 5. And rather than doing 6 times 15, I just divided by 5 here. Right, that goes away, and I just did 15 divided by 5 is 3. If you didn't see that, but otherwise, go through whatever steps you need. All right, and then another example with a couple more binomials here. So we got 3 times. All right, so we got the outside segment 3 times. Okay, be careful here. I got the total of this whole thing, which is x plus 5. Right, so we got 3 plus x plus 2, right? That's the entire thing. Equals the entire thing, or the outside here, which is x plus 1 times, and then if I add all these, I get 1x, 1x, 2x, and positive 1 and negative 1 goes away. Alright, so we got 3x plus 15 equals 2x squared plus 2x. Alright, looks like we got ourselves a quadratic here. So 2x squared minus x minus 15 equals 0. Let's bring back some factoring here. So we got a leading coefficient of x, 2, and of 2x squared, so we have 2 and x. Factors of 15, now of course we got to consider this. This is going to be 3 times 5. This will give me a 2 times negative 3 will give me negative 6. Positive 5 will give me my negative 1. Right, so you have 2x, set these all up set these equal to 0, and you get x is equal to negative 5 over 2 here, and x is equal to 3 over here. That cannot be negative 5 over 2, so your only answer is x equals 3. Bringing back some factoring into geometry here. Alright, let's see what other examples we have on here. I don't think there's too many left. Alright, so then we have another one here. So now we have secants and tangents together. So now we have the secant, the tangent, EA, and EA times what will equal EC times ED. So we're still using this part times the entire part. But since you only have a secant here, a tangent line here, so they're taking EA times EA. Right? So they're using the part of it times the whole of it, so EA times EA, so EA squared is equal to EC times ED. Alright, pretty cool. And again, good luck with those. And let's see what we got here. So we got, here's the tangent, so we're going to do 16 squared is equal to, again, this is going to be x times the sum of those two, which is x plus 8, right? First time we're using x, and the second time we're going to use the entire thing, which is just x plus 8 there. Alright, so we got 256 is equal to x squared plus 8x. Alright, so x squared plus 8x minus 256 equals 0. Right, and then we're going to find factors of 256 that gives you 18. And if you're noticing that you're not getting anything to equal to 8x, then looks like we're going to be using our good old quadratic formula. Alright, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So hopefully you recall that quadratic formula there again. Sorry, I just had to pause you guys out. Put it back. Plug in these numbers. Remember, your a is 1, your b is 8, and your c is negative 256. Enjoy that. I'll let you guys do that. If you're stuck on the quadratic formula, by all means, definitely ask me. But you should get x is equal to negative 4 plus or minus 4 radical 17. All right, and then of those, just make sure that both answers are correct. And make sure none of them can be negative, right? So negative 4 minus the 4 radical 17 won't work, so you can get rid of that one. Negative 4 plus 4 radical 17 will work, and you'll get an answer roughly around, if you do this on your calculator, about 12.49. And that'll be it. Alright, I mean, there's other ways to factor. You guys could do completing the square, quadratic formula, or whatever works. Alright, and I think there's one more. Let's see what we got. Example 4, find the radius of the circle. Alright, and you have 20 is the outside, so you know 20 squared is equal to 8 times. And now all of this, remember, just from here to here is r, 1r, 1r, and 8, so 2r plus 8. Alright, so we got 400 equals 8 times 2r plus 8. You could easily divide by 8 right away, and you get 50 is equal to 2r plus 8. 2r is equal to 42, and r is equal to 21. Alright, and here's another example in the book, and then here's a couple practice problems for you guys that are in the book, the monitoring progress. Let's just run through these real quick. So we have the outside tangent, x squared is equal to 1 times 3 plus 1, right? So just adding the segments. So x squared is equal to 4, x is equal to plus or minus 2, but we're only going to take the positive 2 there. Alright, then you have 7 squared, right? That's the outside line, equals 5 times x plus 5. So 49 is equal to 5x plus 25. And subtract the 25 and you get 24 is equal to 5x divided by 5 divided by 5, and x is equal to 24 over 5. And one last one there for number 7 is you have 12. 12 squared, that's the outside one, equals x plus times x plus 10. Alright, looks like we're going to get quadratic on this one, so you'll have x squared plus 10x equals, just joking, equals 144. Alright, all I did was just flip these, just like to keep my x on the left. So x squared plus 10x minus 144 equals 0. And then either you're going to factor this nicely, or you're going to use the quadratic formula. And playing around with some numbers, you'll see that 144 is divisible by 8, and you get 18 and 10. Yep, so 18 times 10 is, no, just joking, 18 times 8. So I'm going to say 18 times 8 is 144. This one's going to be positive, this one's going to be negative. All equal to 0, x equals 8, x equals negative 18, and we're going to take the x equals 8 and not the negative. And one last one. So in example 4, CB, alright, so we changed this one. Same kind of problem, CB is equal to 35, so I changed that already, and CE is equal to 14. Alright, so my numbers are just going to get a little bit bigger here. no big deal. So CB is 35 squared equals 14 times 2r plus 14. All right, 35 squared is 1225 equals 14 times 2r plus 14. I really doubt that 1225 is divisible by 14, but hey, I guess you never know. I would hope for that one, but that doesn't happen. And what you get, 87.5 equals 2r plus 14. Subtract 14 from both sides. You get 73.5 equals 2r. And then you can divide that by 2, and you get your r is equal to 36.75. And I think that's what they're looking for there. All right. So there's your first 8 examples. In the monitoring progress in lesson 10.6. We got one more lesson to go. We got 10.7. See you in the next video.